Let's
Hello,
go.
hello. Well, hi, how are you?
My pleasure, Mustafa. Again, as always, I
As
love
always,
doing podcasts with you.
now it's pleasure to have you guys around, and I learn every time I meet you guys, get new things from different regions. That's the best part of Let's Talk About Data. And today again is a special session. It's a live demo, and for everyone, Val is okay. I'll let Val
Yeah.
tell about himself and his tool. Yeah, Val.
Hi, everyone. So I'm Val. I'm a co-founder and CEO of company we founded with Farid called IOblend. We specialize in data integration of all sorts, right? So this is the core of our sort of philosophy, and it's always been what we do within our company. So the what we specialize in is moving data integration technology to the next level. I mean, you all guys done, your standard, Informaticas, Talent, Five Trends, all into the warehouse or the lake. Then you do processing inside the warehouse, and then you have some kind of serving layer, whether it goes to the ML training models or it goes into, general BI analytics, dashboards, Excel spreadsheets, what have you, right? Whether it's a manual processing, batch processing, automated processing, all of this is basically what data engineers do day in, day out, right? So we've been through this journey for many years. Farid's probably, been through this from the day he was born. And so we always wanted to move this game a bit forward and make it easier, make it simpler, make it more automated, make it more powerful in terms of the feature set that you can have at your disposal to do data integration much more effectively and efficiently, right? So that's the philosophy behind IOblend, and we strive to deliver that mission pretty much on a daily basis. So the latest thing that we've got to is around feature store, right? So we've been working around the AI ML for quite a while already. And what prompted sort of my kind of question around are we doing it always the same way was when Databricks just bought Tecton the other week, right? And I thought, okay, well, so the current model is you sort of bring the data into a feature store, feature processing engine, and then you do all the work there, essentially running in warehouse or in the lake. And then we went through all our capabilities and said, well, hang on a second. There is a lot of the stuff that we already do in memory while the data is traveling before you ever land in the warehouse. You can do it quicker, more efficiently, and then crucially on any infrastructure, right? So you're not necessarily going yourself, get locked in into a particular architecture or framework. You now have the ability to do it anywhere and however you like with the power of a tool set behind your initiative, right? So this is sort of where we got to. And I said, okay, well, Mustafa, we got to tell the world about this, right?
Yeah, yeah, yeah.
Because
I
this is
love your
something
tool actually.
different.
Yeah. Mm.
So here we are. So this is kind of what got us there. We've been around for the last 6 years. Our work mainly involves, core that could, bread and butter data integrations, migrations, CRM, ERP kind of systems. Lately, we've got into Agentic AI, so you can embed AI agents inside IOblend tool and directly execute them there. So you can do, bring unstructured documents into your data pipelines, ground the data with the structured data on the fly. You can do data quality validations, all kind of that kind of stuff. So this is what we do day in, day out. But and then we kind of said, okay, well, we can also now provide feature engineering to MLOps teams by essentially eliminating a layer or two of complexity uh, by just recycling the same capabilities into this sort of direction. And so
And
that's what
just
we're
to
going
add
to
to
be
that, so
showcasing today.
and just to add to that, it becomes more powerful when you look at some of our use cases. So as Val kind of mentioned, some of the work that we're doing now is where we're generating agentic AI using IOblend. So that means we create agents, or we give the capability to create agents within IOblend, as well as interfacing it with AI's capability of being able to stream data from anywhere and create new data assets. And so what we've found with that is, as we are passing the information from one agent to the other, we're then augmenting that with new feature sets that we're generating, which is really cool. So we then can stream in real time data from your data stores, from your operational systems. We can create new features on the fly, apply it to the agents, which then are executing and producing outputs, which then sends that on to the next agent to generate the overall outcome or process that you're trying to produce within your agentic AI. So that's how we've kind of gone, oh, wow, okay, so we do the full end-to-end MLOps operations here, as well as supporting our general bread and butter of data integrations and generating data warehouses and data lakes, which is really, really cool.
Okay. Now I'm going to wear my solution architect cap before we jump into the demo, right? Just to get something clear for our audience as well, because we already had a session on IOblend, I think 6 months back, well, right? Or maybe a year back. And so can you guys just quickly, within couple of minutes, explain what IOblend overall do? Because I know it do everything in the Spark engine. Maybe our audience are not aware, because once we simply jump on the feature, they'll be lost. Just give a background what IOblend do. Yeah.
Sure. Okay. So perhaps I'll address this to start off with.
Yeah.
I'll give the more technical answer, and then Val can water it down a little bit. So with an architecture hat on, so in order to, IOblend's premise is the ability to move data from one place to the other and execute any transformations you need to do on that in memory. So as Val mentioned, what you generally tend to find nowadays is most of your processing is done on the actual lakehouse itself. So you have to migrate your data to the lakehouse, buy into the architecture and infrastructure of that lakehouse, and then do all your manipulation on that. So it ties you down to one particular provider in order to do that. B, you have to do everything with that cloud, that cloud environment, which becomes quite expensive. So as I said, our premise is our ability to move data anywhere to anywhere, but we do that all in transit. So any transformations that you need to execute on that data to get it into a fit state. So let's say you want to extract data from several operational systems, and it's going to land into your lakehouse or even your data warehouse. Those transformations of actually merging that data, producing the data quality, doing the change data capture, doing all the archiving, doing all the error processing, doing all the monitoring is all done within the IOblend engine, and it's all done within the stream. So all in memory. So all of that is done. So your data is prepped before it lands in your actual lakehouse itself. So that reduces the overall cost and complexity of doing that. Now, how do we do this? So you mentioned Spark. So IOblend is actually a set of modules so we use Spark as our framework. So Spark is a fantastic application framework for doing distributed compute and being able to move data at high velocity, high volume, and high veracity. So why would you not want to use it? The problem with Spark is it's extremely difficult. You need very, very strong engineers who understand how to generate Spark data pipelines, how to manage those Spark environments in order to do that. And that's where IOblend came from. So I was working on a project many, many years ago. We were building a series of Spark data pipelines to move data from several operational systems into our data lake, which was then going to be used to inform our ML applications to allow us to do demand management. The problem we were finding is when I originally costed that up as an architect, as the lead architect on there, and we were using Spark to do that, we were blowing the budget. And we were blowing the budget purely because of the cost of the engineers, the amount of time it was taking for those engineers to create those data pipelines to do that. So therefore it was, okay, well, this is really costly. Surely we can create some sort of framework which allows us to reduce this barrier of entry, which is around the cost, which is around the resources. So if we can create a framework which does all the heavy lifting for you, so therefore I can have much cheaper resources doing 80%. So I can have my data scientists coming in and generating a Spark data pipeline, or even my data analysts, because all they need is a SQL. Tell them what the business logic is via SQL, and then Spark would generate IOblend would generate all the Spark data pipeline code needed in the background for you. And not only will it do that, it will do some cool things like, well, actually, I also need to be able to do a change data capture and stream from JDBC databases, any JDBC database. That's pretty difficult, if not impossible, using Spark. So therefore, we built that into IOblend. So now you can connect to any JDBC database and you can stream and have change data capture directly from that built into IOblend. You don't need to code anything. It's all done for you. So that's where IOblend was then born. So we created a framework which uses Spark as the background, which generates and automates the creation of all of these data pipelines for you without you having to write any code. So we reduce the complexity of generating these solutions, which means I can then use resources which don't need Spark experience. And so we use this kind of 80-20 rule, which says 80% of the data pipelines that you need to generate, you can have a data scientist or a lower entry, sort of a basic developer developing it, or even your data analyst doing it. And they can do that just in SQL. So you can write the business logic using SQL and then IOblend will convert it. However, there is that 20% where actually it's rather complex stuff that you need to write. And that's where IOblend then gives you the ability, and that's where you have your data engineers, which will then use IOblend and write more complex data pipelines, where you have to step out of general SQL and you have to write Python code. So IOblend gives you that capability. And that's what we do. So we sit on top of Spark as a distributed framework. We make life a lot simpler for engineers. So we have an IDE which allows engineers to do drag, or any resource to do drag and drop to create these data pipelines. And we mask all the complexities that engineers typically have to build around CDC, around monitoring, around error management, around logging, and around feature selection. All of that is done for you, as well as some cool stuff like we will create the structures for your data, for your lakehouse or your data warehouse for you, and we will maintain those as well. So all of these things that you have to have engineers which spend a lot of time writing, all has been wrapped up and embedded into IOblend, and IOblend does that automatically for you. Val,
Okay.
is there anything you want to add to that?
Awesome.
The only thing is, because we're sort of with the other differentiator of us versus the, say, SaaS models, is that we are a desktop app, so you can deploy it within the security net of your organization, for instance, right? So that makes it automatically, super secure, because
we can put it into
the data
VMs.
never leaves.
Exactly. We can put it into VM. Just one question before we go into agentic, which will raise another question, few more questions. Just for our audience, maybe Farid can also chip in as well. You guys do all kind of monitoring and logging everything, right? All logging is done because when you are playing or doing everything on the fly, that audit and regulatory compliance things come in picture, that we need to track back everything. Is your tool managing all those loggings?
Yes, absolutely. So that's one of the cool things that we do. We monitor and we log everything. So
Awesome.
for example, we don't do updates, we do inserts. So what that means is we have a full transactional log of all changes which are happening to your data. So IOblend adds additional metadata to all of the we call them targets, or it's basically where you're going to end your data or where you're going to put your data, and it captures and gives you the ability to have full auditability, so full data lineage, not just at the structure level but at the record level, so you can see what records have changed, when they have changed. So that is absolutely immense when it comes to doing an audit. So whether you're doing fraud detection and you want to identify anything fraudulent which has happened to a system, or whether you're doing a financial audit log on your data, it gives you that full capability out of the box. You don't need to write anything.
Awesome. Now, one more question before we jump into the demo. You mentioned that you guys are creating agents on the fly. The other day I was doing some investigation. There are around 13, 14 types of agents, different roles, XYZ. So when you say you create an agent within the IOblend, is it something you guys have the library? There are producer agents, there are execution agents, there are data quality agents. How do you do that? Maybe you can just explain it later. We go into demo.
Sure. Data quality is something separate. So we have data quality already baked into IOblend. So it gives you the capability to run dedupes and generate data quality routines within IOblend directly. So that's kind of different to the actual agents itself. In terms of our capability of how we do agents, you hit the nail on the head. There are so many different types out there. So it would be restrictive if you had any tool which says, here are the agents that we offer. So we follow the same sort of mantra within agents that we generally have for IOblend. We keep it simple. You know what you need to build, and you know what tools you want to use. So we have this concept within IOblend of transforms, yeah. And there are two types of transforms within IOblend. The first one is internal. We call it internal, and basically this goes back to where I was saying you can have your data scientist, or your data analyst, or your beginner sort of data engineers just write in SQL code. And that's what you write your SQL code within an internal transform. Then we have this other concept called an external transform. Now, this external transform gives you the ability to write Python code. And that's where we have created our agents. So the external transform is quite important and very, very special because it integrates all of the features that you already have within IOblend, such as CDC, such as data lineage, such as error management, error logging. And it gives you access to all of the data which is being generated, as Val will show you with each one of our components. But it then allows you to do some special stuff. So, for example, with one of our clients right now, we're creating agentic or AI agentic processes where we are reading in sort of data from different types of unstructured data. We're formatting that, and we put it into the right structure. We're running data quality rules on that. And in that process, we are using our external transforms where we bring in LangChain, where we are then using LangChain to write our models within our external transform while bringing in all the features that IOblend has generated on the fly that you need to use as well. So that's how we do it. So it gives you the flexibility to use any model, any type of agent that you want to generate with any type of framework within IOblend, giving you that complete flexibility while giving you the ability of integrating with any of the sources that you need to supply to it as a feature.
Wow, Val, you are going to create a tool like Oracle or IBM, is it? This tool is getting bigger and bigger. Whenever I meet you, it has 10 more features in it.
To be honest with you, a lot of these features are fundamental to the core design features of IOblend. So because as a person who's done this for many, many years and come up against this problem time and time again, that's why IOblend came up with. That's how I came up with IOblend, because I have constantly struggled with these same problems, building pipelines which are moving data from one place to other that have to be in real time, high velocity, high volume, high veracity, unstructured data, and it takes a long time. The architectures are there in terms of the frameworks like Spark and stuff like that, but it takes a long time to build those things from scratch, and it's very expensive in terms of the resources. Surely I must be able to generalize those processes to create an open architecture which allows us to do this much, much easier, which embeds a lot of the sort of the generic processes that I've talked about within your pipeline, so you don't have to do it. So it reduces the time, reduces the cost, and just makes it a whole lot easier. And that's how it was born.
Awesome, awesome. I think now as we take this advantage, Farid is here. Farid, before we jump into this MLOps by IOblend, can you also give a little bit overview of what is MLOps and how you're going to which piece of MLOps, because MLOps is complete picture, and Val mentioned me it's not a complete MLOps. You picked up few pieces. So Farid, again, floor is yours. Just give us a quick overview of MLOps.
Sure. So as you said, there are many definitions for ML. So what I'll do is I'll frame it in terms of how we're using it and how we're using it with our clients right now. So from our perspective, MLOps is the ability to be able to generate your models, to be able to train your models, to be able to move it from one environment to another, and then the ability to actually productionize those models as well. And when I say models, it's not just about, okay, I'm going to create one LLM or I'm going to create one model. This is about creating true AI or agentic AI processes. And what does that mean? That means, well, actually, I've got lots of models that I'm stringing together and they are generating output, which are then passing it on to other models. So again, going back to an example that we are currently implementing with one of our customers, we're pulling unstructured data from documents. I don't think I'll describe what documents, otherwise it'll give the agent, but it's with a big government agency. We're pulling unstructured data together. And so that's the first LLM. The first LLM has to be able to extract that data from these unstructured documents, and it needs to be able to format it in a particular way, and it needs to run data quality. So it needs to check that. So in here, we have two LLMs, the one which is extracting information, the second one which is then formatting it, the second one which is then checking that data for data quality. Okay. So within IOblend, we have got a data pipeline which allows us to pull that in. So that's the first bit. We've generated it into one agentic process, which is pulling the data from those documents. Then it's then taking that data and then it's doing a basic data quality check by passing it to another agentic process, which then looks at things like, are the dates formatted correctly? Are the durations that it specified correct? Then it passes it on to another agentic AI process. Then it passes on to another data quality process, which is then has to generate a feature set, which is pulling master data from from the organization's operational system, such as, is the address correct? Is the client name correct? Does this client already exist? What do I need to do with this data? So then it's generating that data and it's passing on to the next agentic process, which is then saying, okay, so now I've got this data, what am I going to do with it? Well, what I want to do is check that it's valid, and I want to be able to insert it into the appropriate target system. In this case, it's pushing it into an end operational system via an API. And if it's not correct, what I want to do is then I want to generate an appropriate readable message that I can send to the users, as well as the error itself, so the user can then process it and then they can make the relevant changes to it and decide what to do with it. So that end-to-end process is what we call MLOps from a production point of view. We give it the capability of creating agentic AI processes and stringing them together. Then there's the other side of MLOps is, well, how do I actually go about testing this stuff? So using the same data pipeline you've generated, you can then use the features of testing. So generating your testing data, your training data, and running it through it as well. There's a bigger piece of MLOps, which I kind of described in terms of how do you move it from one environment to another. So that's like your traditional. Exactly. That's your traditional sort of data ops. So I've created it. I've created my dev environment. Now I need to run it to my test environment. Then I need to move to production environment. Then I need to run all the tests around it in terms of regression, my unit, my system test as well. That element of it we don't do, because there are lots of tools outside the box which already do that. Yeah. So for example, some of the tool sets that we use with our clients, they'll use. Oh, okay. I thought that was a question. So we use so we use some of the traditional tools out there which allow us to do that. So things like Bitbucket, which allow us to maintain the core repositories. We use sort of the traditional tools within Azure and AWS, which allows you to move and migrate your features and your products from one environment to the other. So there's no need to repeat that. But the rest of that, as I've just described, we managed to do within the architecture and the framework of IOblend. Does that answer your questions?
No, that was good enough to jump into the demo. So, Val, floor is all yours. Thank you, Farid, for the descriptive explanation.
You're welcome.
Okay, I need to allow that. Okay, allowed.
Yes. Okay. Let's see. All right. So let's go here.
Okay, good.
Can everybody see my screen?
It's still processing. No, yeah, we can see that. Yeah.
Okay, so not sure how I can get rid of that top bit if it's blocking a little bit. Apologies.
It's okay.
Right. So what you guys are seeing is the let me hide this as well. Oh. There we go. Move that out of the way. Is the front end to our application. So as Farid was alluding, we've got a Spark engine sitting behind the scenes with our additional elements and logic built into it. And then the front end is how you interact. Now, this is a desktop application, so you can deploy it, on virtual machines, containers, or as like here on my laptop. It comes fully packaged.
Sorry, Val, I'll just add to that. So Val said Spark engine. So actually there are two components to IOblend. So there's the IOblend designer, which is what you see here. And this is what I described previously in terms of the developers use this IDE to develop the pipelines. And then we have what we call the IOblend engine, which uses Spark underneath that. Yeah. And that's the bit which actually does the clever stuff around the conversion of what you're trying to do into your Spark code and adds all the IOblend sweetness to it. Sorry, Val, back to you.
No worries. So what we'll do is we design it here, build it, validate, add logic, paths, permissions, all that kind of good stuff. And then once you click this magic button here, which then says execute, then the information is sent to the engine, and then the engine starts doing its magic. And I'll show you both how they interact and so on. So now, in terms of other cool stuff, the engine and the front end don't have to live on the same environment, right? So you can have the engine running in the cloud and this running on the developer machine, and you can pass the pipelines between the information about pipelines to the engine. So you can also have multiple engineers working on the same pipeline because all the components are shareable. You can push them through CI/CD process. Everything's stored as a JSON, so you can even edit it as code if you're not into working on the design window. So it gives you flexibility how to work within your preferred method. So what you guys see here, and I've been a bit cheeky, pre-built a little bit because this will take, maybe a good 40 minutes to do on your own. But this is a Spark pipeline. Now, I built this in 40 minutes, right? And I am not the data engineer. That's my disclaimer. And Farid can vouch for that. And I can do it, right? If I can do it, an analyst can do it, a data scientist can do it. You guys probably can do it in your sleep. It's very, very straightforward the way it's done. So what we're doing here is we are creating a feature. This is structured data, right? We're creating a feature that will then propagate to an offline store and an online sync, where you obviously both are synced because it's the same process that's populating both destinations. And we'll go through step by step what it does here, and I'll show you what the output is. Now, this is how a developer will see this, right? So when you're building, creating, iterating, debugging your pipeline, you'll be doing it through this mechanism. And the great thing about it is iterative. So you go element by element, you're architecting your pipeline, you're testing it as you go. By the time you got to the syncs, your pipeline is pretty much already tested for that it works. So you can then push it out to actual, performance testing and so on. So it speeds up your development time considerably. Now, again, remember, the all IOblend mantra is make engineering simpler, faster, more efficient, right? So that's what we're trying to do. We're sort of trying to eliminate multiple steps in your developer process to bring you closer to the actual products, apps, data consumption, what have you, quicker. Right. So what we start here is we've got a streaming data source, and it could be anything, right? It could be a bus, it could be an API, it could be a JDBC stream or a file. It doesn't matter what it is. As long as it's producing data, it's going to be event-based. So as soon as the new data is coming into that source, IOblend will sniff it out, pick it up, and then they'll start acting upon it, right? Like Farid says, we use change data capture mechanisms, so we will process only the latest data, fresh data that is arriving. So if the data has already been processed, you don't need to go back and recompute the whole thing like you do, say, in the batch job. You will pick up only the latest data and continue forward with it until the next cutoff. We'll call it bookmark, watermark. So the sources can be anything. Again, see how easy it is to do. You just name it, then you specify what type of source do you want to have, and it could be your standard databases. It could be a data frame, and that's what Farid was talking about. Cool features around having an external data brought in via data frame, and you can query that data frame while it's in memory by any other component within the pipeline, which makes it very, very efficient in speed, processing, and flexibility, what you want to do. So you don't need to create tables within a warehouse to then query it. So then you specify if it's a file stream, you can specify what type of file these would be, and obviously they'll process anything. If it's databases, it'll have your standard logins and so on to all of the. If it's got a JDBC connection, ODBC, we're there. We can connect to it. API is a slightly different process, and I'll talk a little bit about it in a second as we go through. So once you've created the source, you've essentially you specify what you wanted to do with the source. So you specify if you want to read the latest records. So if you've got a multiple hours worth of data coming through, you can specify in parallel to create the latest records table. So you can run that through, say, training model or inference models if you're doing, fast processing. So you're running a little window of what you want to count as valid data in your models. You can do deduping on the fly, so you can specify what classifies as duplicate data there. So you can absolutely have that managed for you. You can have here create, and then Farid, by all means, step in. You can talk about the regressions, late arriving data, and windowing, how we manage that part of the crucial equation in
Sure.
stream management.
Sure. So this is something which is common within Spark. So it gives you the ability to set an event window, which says, okay, I'm going to process data within this set period. So I always go back to an example of, previously when I was working for a large retail organization within the UK, we were bringing in transactions from all of the stores across the whole of the UK. And, every night we'd bring in those records and we'd do the appropriate aggregates in order to produce the reports for it. Now, when you're generating if you're doing rolling aggregates, you only want to store so much of that in memory. You don't want to continue to add those aggregates. Otherwise, you're going to consume all that memory and you're going to kill all your resources. So you basically say, okay, I'm going to do these aggregates for an event window. So that's great. So this is a feature which is done within Spark, and Spark would then allow you to then process some late arriving data in accordance with that. However, the problem is that if you then receive data which is much, much later than that event window, so the example I just gave, let's say that I'm streaming all this data in from my stores, and every night I'm going to then close down the event window. I'm going to process it, and I'm going to generate the reports which tell me, the total number of transactions which have been generated split across by all the stores. If I have one of those stores which goes down, the network goes down, let's say it goes down for 2 days. So there's 2 days worth of data and aggregates, let's say 3 days. So 2 days worth of aggregates in terms of reports that I've missed. Let's say it then comes back online. Now, typically what Spark will do is say, well, you're outside the window, I'm going to ignore that data. What IOblend allows you to do is the ability to replay. So once it receives that new data, it will go, okay, there's this concept we call regression or regress. And it will say, would you like us to replay all of the data, all of the transactions, to include this late arriving data for you? So what it does automatically is it archives all of your data for each of your processes, so each of the components that you see on the screen. So therefore, if it receives late arriving data, it gives you the ability, and it will then rerun the pipeline and load all of that old data and recreate the aggregates. So the aggregates for the previous day that you would not have got, it regenerates those for you. And because we do upserts, which means that we don't lose any of that data, that new data is then placed in your data lake. And because of the way we manage that data lake, because we have the metadata and create the views on top of it, so the user only sees the latest record, then the user then now sees the correct adjusted figures. But what's really important here is that we've given the ability, which no one does, of replaying all of those transactions from any point in time in history up into either the current time or a point that you define, because you may say, actually, I don't need you to rerun all the transactions for the last 2 days, just do it for the last day, that's sufficient. So we give you that capability. So that's something really, really sort of important. I must fire away.
Question. So when you say you can replay it, so it means definitely you are keeping that data somewhere. I'm sure you're not persisting it in the memory. You must be keeping it down there in the lake, right?
Exactly, yes. So basically, we give you the option of where you want to archive that data, and that's generally so we archive it in a file format, and then you archive it. So it depends. If you're running it in the cloud, then you'll use the cloud file system, so S3 or for example. But if you're running this locally on a Windows machine, then you could literally just use a normal sort of file, CSV generated file, which can be stored on your local machine.
So what we are saying is, just for our audience, whatever you want to do, either it is an archive or either you want to, after processing everything you want to store, you can store anywhere. Either it can be RDBMS, it can be a flat file, it can be a lake, anywhere, right?
So for the archiving, the ability to regress, that is only file. The reason why we do file is because it stores, we can compress it and it stores less, it takes up less space and therefore is cheaper. But that's just for archiving. Yeah.
Okay. And that files, if I'm not, sorry, yeah, if I'm not wrong, that files can be stored anywhere, because now we have traditional file systems. We have Hadoop, we have object storage. So that file can be anywhere, right?
Yes, correct.
Okay. Awesome. And what about cloud? Any cloud is fine?
Yep. Again, because so basically you need to remember, so that the Spark engine, the IOblend engine and the IDE, they are installed on your own environment, wherever that environment is. So whether that's local to you or a local machine, or whether it's in the cloud, and we operate with all cloud environments.
Okay, now I'm going to throw one very, very technical question about ingress and egress. The moment you start using cloud, because this normally this increase and increase cost is lost somewhere, and once the bill comes, then you come to know. So normally if you are pushing, I think you get increase or increase, whatever. I'm always confused. Do you guys keep track of that either we are pulling or we are pushing? Sorry, little bit more techy question, but yeah, I do see
It
that.
depends what I think the answer to that is it depends. Everything is tracked within IOblend. So
Okay.
if you're talking from an archiving point of view, absolutely. So we know what data is being stored and where it's being stored, and we know what data we're pulling from, and reports can be generated from that as well. Likewise, with anything within the cloud, if we're pulling it or where we're pushing it, IOblend logs everything. Yep.
Logs
So we
everything.
have
Okay.
it logs everything. So we have full understanding of what's been pushed and what's been pulled.
Okay, awesome, awesome. Please continue. Sorry, my architect hats keep moving, so I keep throwing questions. Yeah.
No, that's perfect. That's the way we prefer it.
Thank you. Yeah.
Perfect. And also, Mustafa, I see some comments popping up. I can't quite see them. If you could, summarize and read them
Nothing.
out, that would
Uh,
be very useful.
Okay, let me go and have a look. You can continue. Yeah.
Yes. So once we've generated a data source, that data is then ingested, like Farid said, into memory, right? So it sits in the data frame. Now, this data frame now can be, it's got a unique name, and it can be queried essentially by any of the components you can create within this pipeline, even other pipelines, right? So in this case, we're creating the next one is a transform. So what we'll do is we put a SQL statement and we just add an additional column to it. Standard NC SQL, very easy to do. Again, this will automatically be converted into Spark and executed, so you don't have to worry about anything behind the scenes. And then in this case, we're doing this sort of a temporary store of streaming data, which we can then either have as an archive. So this next component is pulling out from the archive, but you can technically pull it directly from the transform here and continue with that. So what we do is now we're going to create a feature, right? So we've got a streaming source that we've added a timestamp to. And then what we do is we're going to aggregate that data. We're going to enrich it. We're going to add additional lookups to it. And what happens in the end is we've got a maintained feature of a streaming data augmented by static data in real time, event-based, and then it's ready to serve your ML models, either within offline stores, so you can train it, or your online stores where you can then do inference and continue doing products out of it. So again, interest of time, we only got 15 minutes, so I'll just hop through. So again, the same principle, you define the source, you identify what it is, you tell it what you want to do with it. Then you put a transform, again, SQL based. If it's a more complex transform, you just throw a component on the screen and you can say, look, let's say, I don't know, ABC component, and then you can say it's an external transform, and then it gives you ability to specify what you want to do, where you want to point it. If it's an API connection, you'll point it to an API. We've got a templated code model there, so you can assign that, and then what you do is you'll connect that component to any of the components that you go forward to, and then the model will execute it. So
I think what's really sorry, Val. So I think what's really important here is that what we can see is, as Val has described, we have got a number of streaming sources, and then we have a number of static sources, which collectively we need to bring together in order to generate the features that we want. We talked about these transforms, and I talked about IOblend. It's in terms of its philosophy is keeping things simple. So we only have three processes or three components. We have a source, which are the ones in pink, which basically, as Val said, allows you to pull anything from anywhere. Then we have the green ones, which are the transforms, and that's where we actually generate and pull together the data from your streams and from your static lookups in order to create that feature set. This goes back to what I said before. There are two types: there's the internal transform and the external transform. What Val has described to you is the internal transform, where you write the SQL. And what I should say is that every one of these components, what happens is you can see that each one of these components has a name. That name is really important because it actually creates a Spark data frame by the same name. And every one of those data frames is then accessible by any one of those components that you see within your data pipeline. So that's really important, because that's how, for example, number 5, which is your OOG by step sum transform, that then has access to every single one of those data frames, which is generated by each one of those sources and by other transforms. So as you can see, number 7 actually takes data as well as the output from the transform, the feature which is generated number 5, to create a new feature. So that way we can create features upon features, which is really, really important. What Val is then showing is that the end step is, okay, so we've got two possibilities here. Either this pipeline is used to create the training data that you need in order to train your model, in which case it goes out to what is called the feature store offline sync. Or actually, if this was in production, you could actually take that feature set and then supply it to your model. So I actually can't see it, Val, because it's blocked. But if you could scroll it down the screen, please, so we can see the last one. Yeah, that's it. The online store sync. So that online store sync would actually be another external transform. And that external transform, in the case as I described with some of our clients right now, we will then supply the feature set that we've generated, and we'll pass that on to the actual LLM that you're executing. And then the outcome of that LLM will then pass on to another external transform, which will then, for example, say, I'm running data quality, further data quality checks on it, or actually I'm now going to embed that data into one of my operational systems via an API. So that's how it hangs together in terms of the ability to create your training data, which would go to your feature store, which will then allow you to do your training on the LLM within whatever sort of tool set you're using for generating that LLM, or once you've generated the LLM, you can then run that feature set in real time directly into the LLM and get the output out of it, which is really important. And that's how we bring the whole sort of MLOps from the point of view of being able to create productionized agentic AI processes, from generation of feature set in real time to running that feature set into your agentic process, to then allow the output of that to be then spawned into other agentic process, to creating your end-to-end agentic AI solution that you're generating.
And
I hope that makes sense.
Quickly to add to that. So remember that one of the really key important things around feature generation and maintenance is around data quality. You know where the data is coming from. Can you trust it? So remember, as the data flows through here, you can assign different bits and policies around data quality validations, what you would allow through, what you would quarantine before it ever gets into your training model, so it doesn't contaminate your models, and it doesn't, it minimizes the amount of rework you have to do later. So you kind of have that all maintained for you automatically. So that's very powerful, because normally you would do it inside this feature store.
So, and just in terms of running it, if you're going to run it from the IDE from a testing perspective, then basically you just hit that green arrow on the top right, and it will run. I think Val can show you what.
Yeah, I'm already programmed. So this is, again, developer window. So once it's in production, you don't have to see that. You can absolutely switch it off. But it essentially tells you, what your schemas are, how much data you're ingesting, and this just shows you 10 rows, right?
Val, we can't see it. Val, we can't see it. We're still seeing just the IOblend designer window.
No, actually, I've already zoomed out. I think, Farid, you are zoomed in.
Hold on. Let me do...
okay.
No, I've already zoomed out.
See it now?
Yeah, I can see.
Oh, as long as you can see it, I can't see it, that's fine.
Okay, so I'll talk them through the developer screen. By all means, please stop me if you get... again, Mustafa, I can't see the comments, so if they're relevant to what I'm talking about, please read them out.
No, actually, not many, but someone asked a question: who prepared the training data?
Say again, sorry, Mustafa.
Who prepared the training data?
Who prepared
the training data? Well, in this instance, we have, but again, in terms of how you generally prepare the training data, that's what we've done here. This training data is being generated by this data pipeline. So in this instance, you'd only be running it out to the feature store, and the data is being, so this data pipeline is, in this case, has been generated by Val. who is not a data engineer by any stretch of the imagination. So therefore, anyone can generate this. So either you can have your data scientists, or you can have a data engineer, or even your BAs can be generating this data from a testing perspective. Yeah. So typically in this scenario, it would be your data scientist generating or creating this data pipeline to create the feature set and your training data for them.
Yeah, so no code concept. It's a no code concept, right?
Yes,
exactly.
Correct. Well, it's no code, low code, because then when you're doing the yeah, exactly. Because when you're doing, for example, creating the agentic AI, or yeah, just your agents, then that's when you need to write the code within the external transform. Yeah.
Okay, awesome.
So as
just
Farid
a
was
time
saying,
check. Just a time check.
Yeah.
We have 9 odd minutes. Yeah.
I'll just quickly show how we what kind of metadata we start adding to each process, so you can kind of see we've got timestamps, we've got keys, right? So we can use all of these elements to do lineage, to do error tracking, and all of that good stuff that Farid was talking about. And essentially what it does, it goes step by step. If any of these steps are broken, you can absolutely dig in and see, it'll give you what the error is and so on. And it goes through all the way to the end of the process. And it says, okay, now I've processed this particular data. It will sit and wait until the next event occurs. So if fresh data arrives, otherwise it won't consume your resources. In this case, it's manually set up, but in reality, it'll be automatically running. And it continues in the loop. So you can always dive in, even while the pipeline is running live, and inspect without necessarily disrupting it. So it gives you capability to do all kinds of monitoring and checking while the pipeline is in production.
And just to add, sorry about that, just to add to that, so this is you're looking at in the developer point of view, but in terms of when it's in production, then what happens is IOblend creates the appropriate Spark submit command, which allows you to run this within whatever scheduling sort of system you're using. So whether you're using Crontab or Airflow, you would then schedule that Spark submit, which executes this IOblend data pipeline for you in your operational systems.
I was about to ask that what we can see here is kind of a mapping. So what about workflows? So you are saying workflows is by some other party, you guys will end up creating mappings and someone else will orchestrate, correct?
Well, yes and no. So the actual workflow and the data pipeline workflow is here, as you can see it. So that's created with an IOblend.
Okay.
And you can link pipelines together. So that's fine. Just in terms of the execution of this on your production environment, as I said, it is Spark code. So therefore, you will have a Spark submit, which then will execute the IOblend engine with the appropriate data pipeline. Now, you can do that either, whatever scheduling tool you use to run these. So whether you're using, like I said, something like cronjob, or you can, in some of our clients, we've used Airflow just to schedule it. So it's not so much doing the workflow, it's just scheduling the execution of the actual pipeline itself. But the actual workflow itself is done within IOblend.
Okay, we have a question, and if I'm not wrong, it is what if the CEO requirement changes based on market demand, something like data drift or requirement drift?
Yeah. So again, so that's there are two things. A, in terms of how do you monitor data drift, and then the second one is then how do you actually adjust for data drift. So how do you monitor for data drift? So again with IOblend, you could do the same thing. So you can look at the outputs which have been generated. You can have a look at the whatever parameters you're using to judge efficacy of your model in terms of precision and accuracy and completeness, to identify whether there's any drift in terms of its capability. If you identify a drift, then it can then send out appropriate messages, which then allow you to then adjust your models. So, i.e., if your models need retraining, so that retraining is done outside IOblend. As I said previously, from a training perspective, you use IOblend to generate the feature set and the feature store that you need, and then you'll use the appropriate or whatever tool sets you're currently using to sort of create your models and to then train those models to reset it. The other question, just in terms of model drift, is just there is something which is based around what happens if the data changes as opposed to the actual model itself. So schemas change. Yeah. So that happens from time to time, especially if you're pulling data in from third parties. You may find that you have model drift in accordance with your schemas drifting itself. So
Yes.
again, IOblend identifies that. So what IOblend does is twofold. One, as part of the metadata, it captures the schema of the data that's bringing in, and it also captures when there's changes. So it does a versioning of that for you. So IOblend creates with each one of these playbooks, it creates a JSON file, and within that JSON file, it creates the versioning of the schema that's reading in. The other thing is, if there's schema drifts, so let's say there's additional columns which have been added to it, then IOblend will just ignore it because it's using a select statement, which is pulling just the data that you need. So therefore, your pipeline is continuing. If you change one of the columns, or one of those columns then fails, then IOblend will then generate an error message for you to say, actually, I'm having to stop at this point because the data that you've told me should be here is not here, and this format has changed.
Awesome.
Hopefully that answers your question.
Yep, I think we got the answer. Well, you have 4 minutes left.
Right. Well, no, I'm sort of gone through
Okay.
the journey, right? It's now you guys definitely Q&A.
I can throw one more question, because this is a very developer screen. How, as a data analyst, I can see data?
So that's the great thing. So I actually can't see what you're showing, Val. So I don't know if you are actually showing the output from IOblend. But basically, when you run, so for example, number 4 or even number 1, if you were developing this in an iterative manner, the first thing you do is you'd create number 1, yeah, that first component, which is bringing in that data. You then run that, and then, yeah, now I can see it. And it shows you what data is being generated. So you can see the schema, you can see the data which is being pulled back. So you can actually see what's been generated. And you go, oh, okay, that looks really good. Or actually, I've got this date column in here and it's not quite right. I need to format it. So then you can go back into your IDE, into the designer. You can then create a transform, which then formats that data, and then you can rerun it. Or you don't rerun it, just press run again. So all of this is done interactively. And then you can see the output of that transform, yeah, to say, oh, okay, fine, now it's actually changed the format. I can then go into the next process. So that's the real beauty of this, is we're developing iteratively. You drop a component, you run it, you see what the output is, you understand what changes you need to make, and then you move on to the next step of your data pipeline that you need to generate.
Awesome.
Cool.
Awesome. Cool. I think we are right on there. If anybody want to, just our audience, I can see 10 around people over there. Well, 3 of us are there. 7 are other people. If anybody has any other question, just shoot it in the chat. I can see Amar Jaffrey is asking with his questions, and we have already reverted all those questions.
I know. I just wanted to thank the speakers. It was a wonderful talk. I really enjoyed it. And I would love to invite all of them to Pakistan. And this was a wonderful toss, wonderful discussion on a very relevant data topic, that is linking the metadata with the schema, with the back end, with the front end, and the terminology used. Definitely, I'll be able to get the recording of this video. I will translate into my local language, that is Urdu, and Kalbash knows it very well that our people don't understand much of the English. So I will make it a very simpler, and I'll explain to them. Then I'll get back to you. I again thank all the speakers there. So kind of you. Thank you. Thank you, Kalbash. Thank you.
Pleasure, Mark. Pleasure.
Okay, awesome. So, well, anything, and Fareed, anything at the end of this session? We are all good. Actually, I loved it. And well, I think the more I like it, the more I think we should do again a demo on your actual IOblend, the basic stuff. Because today we were very on MLOps,
Absolutely.
right?
Of course.
So I've seen people are saying that. Let's see what feedback comes. One guy already told me that, hey, how we can open this tool, how we can select. So they are going towards
Of course.
basics. So we can have
Of course.
something on a basics as well. So I'm good. I think I can see John here as well. So John,
Hey,
we are
John.
right at the end of the session. If you want to turn on your camera, you are all welcome. Because John, these guys are creating agents. I was about to ask whether
Hey Val, how you doing? Right?
Yeah, I was
Hey,
about
John.
to ask, are you guys joining your products as well or not? Because Dog is also agents and IOblend also got. So just a quick one.
So we're all getting together at the Big Data London in 2 weeks' time. So there's all that buzz is going that way. So absolutely, John and I, we already have a pint scheduled.
Indeed, indeed, absolutely. Well, we're overdue one actually, Val, aren't we? It's been a while, so
Exactly.
Yeah. Awesome, guys. Okay. Thanks, John, for joining. Thanks, Val. Thanks,
problem.
Farid. I think
Yeah, man,
Andy is also there. It was a great session, and we'll catch up again. Thanks, guys.
Pleasure. Thank you.
Take care. Bye-bye.